Hi everyone, and welcome back to the Beginning Algebra live lecture. It's been a little while since I've done a video. I'm trying to get through the whole class, but it's taken me a while because of holidays and life in general. But anyways, we're on to lesson number 6. So last time we were looking at didn't mean to open that. Last time we were looking at fractions. We were dividing fractions, multiplying fractions. So the thing to remember about multiplying fractions is when you want to multiply two fractions, you multiply from left to right, so top by top, bottom by bottom. And when you want to divide fractions, you rewrite it as a multiplication. So instead of doing a division of a over b divided by c over d, you rewrite this as a over b times d over c. And then you perform the multiplication the same way you normally would. So, we start talking about, actually we didn't talk about this. So at the very beginning of this packet, we talked about factors, like factorization, or maybe this was in the previous one. Oh no, we talked about it at the very beginning. At the very beginning of this, we talked about prime factorization. And one of the reasons we did that was so that we could simplify our fractions. We'll see sorry, I'm kind of going real fast all throughout this thing. You'll see here when we wanted to simplify our fractions, we wrote each number by its prime factorization and then crossed out any common factors. So when we multiplied our fractions down here, we would multiply them, but we would also look at writing each of these numbers that are being multiplied, write them out as their prime factorization so we can cross stuff out. Now, there's one other reason that we might want to use prime factorization, and it's so that we can find what is known as a least common multiple. So a multiple of a number is the product of that number and any other natural number. So, for example, the multiples of 2 are 2, 4, 6, 8, 10, so forth, because you can get that by multiplying. You can get each of those numbers by multiplying 2 by something else. You can multiply 2 by 1 to get 2, 2 by 2 to get 4, 2 by 3 to get 6. So that's why each of those numbers in the red are multiples of 2. Similarly, the multiples of 3 are 3, 6, 9, 12, 15, 18, and so forth. Now, one thing we'll be concerned with is if I list out all the multiples of 3 and all the multiples of 2, which ones do they have in common? The one specifically I'm most concerned with is which smallest one do they have in common? What is the smallest multiple they have in common, known as the least common multiple? So if you look at the examples here, I've listed out all the multiples of 2, all the multiples of 3, and you'll see the first one that they have in common is 12. Okay, so the least common multiple between, I'm sorry, that is not right at all. That is a common multiple. 12 is a common multiple, and 6 is a common multiple. So you'll see that they have multiple common multiples, no pun intended, but the least common multiple between the two is 6. So when I want to find the least common multiple between two numbers, I don't want to have to write out all the multiples of them, because sometimes these least common multiples are like super big numbers, okay? So there is a method for finding this, okay? So actually I meant to do 6, 12, I meant to write them both in there. The next one would be 18 and so forth, okay? So really the least common multiples of 2 and 3 is the smallest, 6, as we said. And you'll notice that all the multiples are all of their common multiples are the multiples of 6. keep saying like the wrong thing tonight. I'm having distracted by stuff, but I'll get there. I'll get focused. Anyways, so the least common multiple of 2 and 3 is 6. So as I said, we don't want to have to write out all of these numbers, all of the multiples of both of them, and try to find where they overlap. We don't want to have to do that every time, especially if we're like have 3 numbers that we're looking for a least common multiple of, or if the least common multiple is really, really high. So there is an actual method that we can use for finding it. And to do it, you use prime factorizations. So what you want to do is write out the prime factorization of each of the numbers you're looking at, and then for any given prime number you see in these prime factorizations, it's going to need to be included in your least common multiple at least once. And you can tell how many times it's going to be in there by the maximum number of times it shows up in these prime factorizations. So what I just said is kind of crazy to just hear me say it. It's much easier to see. So let's look at 14 and 32. Let's say I want to find the least common multiple of that. So step 1 is to write out, so notice it says step 1 is to write the prime factorization of each number. So I can do that. Okay, so 14 is 2 times 7. All right, and 32 is 2 times 16. Well, 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. 32 is one of those ones that's just a whole bunch of 2's, and it's 5 2's. So, okay, so then the next step, if you look back up here, it says, for each different prime number listed, count the maximum number of times it appears in any of the factorizations. Okay? Whichever number has that factor the most, the number of times it appears in that number's prime factorization is the number of times it appears in the LCM. Okay, so let's just think about this. So there's 2 different prime numbers I see here, right? I see a 2, I see some 2's, and I see a 7. So the most I see 2's is here. Okay, and the most I see of 7's is just this one time. So the that was actually my step 2. So I see 1, 7, and 5 2's. Usually I won't write it like this. I'll kind of do it all in one group. So my least common multiple is going to be the product of all of those things I just put in a box. Okay, it's going to be the product of the most 7's and the most 2's. So that's 1 7 and 5 2's. Well, remember the 5 2's, that was just 32, right? So this is whatever 7 times 32 is. So that's 120 plus 14, or 7 times 32 is 224. So 224 is the least common multiple of 14 and 32. Now, we did not want to have to write out all the multiples of 14 and all the multiples of 32 to get to that, because I would have had to have written out 32, I would have had to have written out 7 different multiples of 32 before I would have even gotten to that. So let's try it again. Let's just keep trying it and see how it works. So we've got a 9, a 24, and a 56. So 9 is 3 times 3. That was not too bad. Now you can also write these with exponents if you prefer, if that makes it easier for you. I like to just write it fully out because it really drives it home for me. So let's see, 24 is divisible by 2. It's 2 times 12. And 12 is also divisible by 2 because it's 2 times 6. And 6 is 2 times 3. Okay? All right, 56 is 2 times, what is that? 2 times 25 would be 50. So it's going to be 2 times 28. Let's just, yep, 28. So I'm just going to use a calculator for it. I don't need to do all this in my head. So 2 times 28, well, actually, let me do this. 56. I know it's divisible by 2. Gives me 28. Let's try dividing it by 2 again. 14. So that's that 2 I just divided it by. Let's divide it by 2 again. There we go. And then 7 is prime, so we can stop. Okay, so I see some 3s, I see some 2s, and I see some 7s. So I know I need some 2s. So the LCM is going to need some 2s, some 3s, and some 7s in it. Okay, so now we just need to figure out how many 2s, how many 3s, how many 7s. So I figure out how many 2s there are by looking at the list and seeing, okay, well, who has the most 2s? Well, 24 and 56 both have 3 2s. So, you know, we can say either one. It doesn't really matter. They both have 3 2s. So I'm going to need 3 2s here. So I'm going to make a little exponent of 3. Who has the most 3s? Well, 9 has a total of 2 3s. So I'm going to take 2 3s from that. Okay. So 24 had some 3s, didn't have as many though, so we took them from 9. So who has the most 7s? 56. So I'm going to take the 1, that's just 1, so I'll put a little exponent of 1 there. So this is going to be, notice I've got all of 56 boxed in and all of 9 boxed in, and nothing of 24 boxed in. So 24 did not add to the least common multiple at all. If we had just asked for the least common multiple of 9 and 56, we would have gotten the same answer. So that's kind of interesting. But it also tells me I know that the answer is just 9 times 56, because these two pieces right here are 56, right? And then the one in the middle is 9. So I'm just going to do... Or, you know, I could stick it in the calculator exactly like that. I could do 2 to the 3rd times 3 squared, 72. Oh, sorry. Let me miss that. Times 7. I missed the 7 on there. So 504. Okay. So 504. I could have also just done, like I was just saying, 56 times 9. 504. So 504, keep losing my pen here, keeps wanting to be a scalar thing, is the least common multiple of 9, 24, and 56. Okay, let's do some more. So 4, 20, and 40. So let's do some math here. So 4 is 2 times 2. 20 is 4 times 5, right? But 4 is 2 times 2, and then 5 is prime, so I'll just write that. And then 40 is just 20 times 2, so it's 2 times what I had just written, so 2, 2, 5. Okay, so first thing I'm going to do after I've done this is I'm going to scan through that and say, okay, what unique prime numbers do I see in here? So I see some 2s and I see some 5s. Those are the only unique prime numbers I see. Okay, well, how many of these do I need? Who has the most 2s? Well, in this case, 40 has the most 2s. So I'm going to need 3 2s. And who has the most 5s? In this case, 5 has the most 2s. 40 has the most 5s. It has 1. So I need 1 5. So it's just 8 times 5, which is 40. Now notice once again we boxed in one number completely, and we fully boxed in the number 40 and not the numbers 4 or 20. Now the reason what happened with this was actually kind of special. 40 is a multiple of 4 and 40 is a multiple of 20. So whenever you have 3 numbers where one of the numbers is a multiple of the other, so let's just think of it as 2. If I just gave you 20 and 40 and I asked you what the least common multiple was. If I gave you 2 numbers and ask you what the least common multiple is, then the bigger one's going to just be the least common multiple because it's a multiple of both of those things. So when one or more of the numbers in the set is a multiple of another, the LCM is just the larger number in the set. Okay. Let's try another one. So we've got 5, 7, and 11. Well, the prime factorization of 5 is just 5, and the prime factorization of 7 is just 7, and the prime factorization of 11 is just 11. Don't put times 1, because remember, 1 is not a prime number. I know it's tempting to want to do that. So our least, this one's going to feel kind of silly, but we're going to go through the motions anyways. The least common multiple needs to contain 5s, 7s, and 11s. I have at most 1 5, at most 1 7, and at most 1 11. So it's just 5 times 7 times 11. 5 times 7 times 11, or 385. So this is another unique case in the fact that all three of those numbers were prime. If all the numbers you're looking for, looking at are prime, their least common multiple is just the product of them. Okay. All right, let's look at another one. So 25, 49, and 72. All right, 25 is 5 times 5, right? And 49 is 7 times 7. And 72 is 2 divisible by 2 because it ends in a 2. So let's just do 72 divided by 2. It's 36, so that's divisible by 2 as well. Times 2 divided by 2. And then 9 is 3 times 3. Now, if you're doing this in the calculator the way I was just doing and you start getting lost, sometimes it can be confusing, like, oh, did I write down all the 2's that I just did? You want to just look at this division here, and you can see I did divided by 2 three times, so there should be 3 2's listed there. Okay. All right. So my least common multiple needs to contain at least one of every unique prime number I see there. I see some 2's. So I need a 2. I see some 3's, so I need a 3. I see some 5's, and I see some 7's. Okay, so now I just need to figure out how many I need of each. Who has the most 2's? 72 does. And I'm not going to use color coding. I'm just going to use the black here. So there were 3 there, so I need 3 2's. Who has the most 3's? 72 does. It has 2. Who has the most 5's? 25 does. So we're going to take all of the 5's from 25. And who has the most 7's? 49. So I'm going to take the 2 5's from there. So in this case, I'm going to just do, I can type out 2 to the third times 3 squared, but notice everything is blocked in. So I'm just doing 25 times 49 times 72. Ooh, that's a big number. 88200. 88,200. So these three numbers are what is known as relatively prime. Relatively prime numbers are numbers that are prime relative to themselves, or relative to each other, which doesn't really define that any further because I'm just using the same words. But what that means is that they share no common prime factors. Okay, so notice nothing in here was in any of the other ones. They shared no common prime factors, so they are called relatively prime. So if you have two numbers that are relatively prime to each other, then it's going to work the same way as if they were just prime numbers. You're just going to multiply them all together. Okay, so why the heck were we doing this? Why are we doing this least common multiple stuff? There's two reasons. One, it's going to allow us to solve some kind of word problems. It's also going to allow us to do some more stuff with fractions, which we'll do in a second. But the thing with the word problems is whenever you have anything where you're trying to find cycles that overlap, it generally is a least common multiple problem. Okay, so for example, John and Becky are brother and sister. John visits their grandmother every 12 days, and Becky visits their grandmother every 14 days. They're both visiting their grandmother today. How many days will it be until they visit their grandmother together again. So grandma really wants to know when both of her grandbabies are going to be in there at the same time. So she pulls out her calculator and figures out the least common multiple of 12 and 14 and says, well, this is when they're going to happen. Now she could go on her calendar and mark every 12 days for John and mark every 14 days for Becky. And she probably was doing that anyways, right? And then just see where they overlap. She could do that. But she could also find it more quickly by doing this. So let's figure it out. First thing we want to do is find the least common multiple of 12 and 14. So we've got a 12, we've got a 14. So 12 is 2 times 6. 6 is 2 times 3. 14 is 2 times 7. Okay, so my least common multiple needs to contain, if I look over there, I need to have at least one of every unique prime number I see there. I see some 2's, so I need at least one 2. I see some 3, well, I see a 3, so I need at least one 3. And I see a 7. So if I look here, I'll see, now I just need to figure out how many 2's I need, how many 3's, how many 7's. Well, the maximum number of 2's I see is 2. So I'm going to need 2 2's. The maximum number of 3's I see is 1. So I need 1 3. And the maximum number of 7's I see is 1. So I need 1 7. Just as a side note, I recommend that when you're doing these least common multiple problems, even though anything raised to the 1 is just itself, you're not really doing anything, I still recommend writing the little 1 there, because it's almost like a little check mark. Like, yes, I checked that how many 3's I need. I know I need 1. It's letting yourself know I definitely have the right amount of 3's in this. Okay, so it's just 12 times 7, or 84. So the least common multiple of 12 and 14 is 84. So that means Becky and John will visit together in 84 days. And every 84 days, Becky and John will visit on the same day. So whenever you see anything like cycles, like this happens, this thing goes this speed, or this goes around the track this many times, this goes around the track that many times, whatever. There's a bunch of different kinds of problems you'll see with this, but it's always about cycles and when do these cycles overlap. It's usually going to be a least common multiple problem. Oh, here we go. So a radio station is giving away free $100 bills to every 100 callers and a concert ticket to every 32 callers. How many callers must get through before one of them wins a $100 bill and a concert ticket? So to do this, I need to find the least common multiple. So of the two numbers that represent like the cycles are the 100 callers and 32 callers. So I want to find the least common multiple of those two numbers. So 100 and 32. So 100 is 4 times 25. So 2 times 2 times 5 times 5. Okay. So, and if you don't think of it that way, remember you can just do 100 divided by 2. Okay, and then I know that's divisible by 2, so divided by 2. And I know that's not divisible by 2, so I can do divided by 5. And then 5. And then you just say, oh, it's just the sum of, or it's the product of all of these things. 2, 2, 5, 5. Okay. Now 32 is one of those ones that's a whole bunch of 2's. In this case, it's actually the one that's 5 2's. I remember it because 3 plus 2 is 5. It's just like a little trick I have in my head. But also, we literally just had 32, so I remember it from that too. But it's just 5 2's. So 1, 2, 3, 4, 5. So the least common multiple is going to need to contain, I see some 2's, I see some 5's, some 2's, and some 5's. Who has the most 2's? In this case, 32. It's got 5 of them. So I'll need 5 in my least common multiple. Who has the most 5's? 100. It's got 2 of them. so I need 2. So I need to do 32 times 25, or 800. Excuse me. So the least common multiple of 132 is 800. So the 800th caller will receive a $100 bill and a concert ticket. And in fact, if they just keep doing this concert, I don't know why they would, but if they kept doing it, every 800th caller will get both prizes. Okay, so I know it feels like we kind of like derailed for a minute, because it's like, why are we talking about word problems? We were talking about fractions. What's going on here? The reason we needed to talk about talk about least common multiples, is to be able to add and subtract fractions, you need to use least common multiples. Okay, so notice we already talked about multiplication and division. We talked about those already. But we completely skipped addition and subtraction. And that's because addition and subtraction with fractions takes a little bit more work than multiplication and division. So whenever you want to add or subtract fractions, you can only do it if they have the exact same denominator. So if they don't have the exact same denominator, you essentially, and I'm kind of jumping ahead here and telling you like the secret thing I'm going to tell you in a few pages, but if they don't have the same denominator, you have to rewrite them so that they do have the same denominator. Okay, so if you want to add and subtract fractions, it's actually not too bad if they have the same denominator. You just add their numerators up or subtract their numerators. So if I want to add 1/9 and 2/9, I just do, it's over 9, and it's 1 plus 2, so it's 3/9. Okay, and then remember, you need to make sure you simplify. Those cross out, so it's 1/3. Now, remember what these represent. A 9th is like a piece of a pie that's a sliver, that's it's a shape that represents 1/9. Okay, so if you have the piece of the pie, 1/9 means I cut it into 9 pieces and it's one of them. Okay, so when you look at these fractions, think of it as I have one of this thing called a 9th, plus 2 more of these things called a 9th. So when you think of it that way, I have one of this thing called a 9th. I have 2 more of these things called a 9th. It makes you remember that, oh, okay, that makes sense that it's 3/9. Okay, I had 1 piece of pie, now 2 more pieces of pie, I have 3 pieces of pie. The pieces of pies just happen to be called 9ths. Okay. Same with subtraction, you do the same thing, you just subtract the numerator, so the denominator is going to be the same. We're not changing the unit of measure on it, it's still just going to be, we're not changing the size of these slices of pies. I have 7 of these things called sixths. It's really hard to say. I'm going to take away one of them. So I'm going to have 6 of these things called sixths, which actually ends up being a whole, one whole pie. Okay. So if I want to do it with this one, I have 11 plus 5 over 15. So it's going to be 16 over 15. Okay, so remember the denominator just stays the same. Just you carry it on over, and then you add the numerators, or add or subtract the numerators. Okay. Let's try it with this last one. So denominator is going to be 1/3, and the numerator is going to be 2 plus 5. So it's just going to be 7/3. Now, in most cases, you want to leave your fraction like that, 7/3, an improper fraction. A lot of students don't like improper fractions, and then they want to go ahead and convert it to a mixed fraction. But, excuse me, but usually it's best to leave it in that form. It's easier to do math with. So unless you're specifically asked to convert it to a mixed fraction, leave it as an improper one. Okay, so why did I talk about least common multiples? I told you you were going to need them to be able to add and subtract fractions. I also told you that you can only add and subtract fractions if they have the same denominator. Okay, so to add and subtract fractions, you use the concept of a least common denominator, or LCD. And all the LCD is the least common multiple of the denominators. Okay, so if you want to add two fractions, first thing you got to do is find the LCM of the denominators, which is known as the LCD. And then you rewrite the fractions with that new denominator using the concept of equivalent fractions. So let's just do this one step by step. Sorry, I had to get some water. My throat hurts. Okay. So first thing is the LCM of 5 and 7. Well, remember when we talked about if they're both prime, then the LCM is just the product of the two, right? So it's just 5 times 7, which is 35. I'm going to need to use my thinner one for here. 35. Therefore, the least common denominator is 35. Okay, so if I want to add these two fractions, I've got 4 over 5 plus 6 over 7. I need to rewrite them so that they both have the same denominator. I want them both to have a denominator of 35. Okay, so I want them both to have a denominator of 35. Because that's the least common denominator. So I got to figure out, okay, well, what do I need to multiply the denominator of 4/5? What do I need to multiply 5 by to get 35? Well, 5 gets multiplied by 7 to get 35. But when it comes to fractions, you can't just multiply the bottom by whatever the heck you want, unless you also multiply the numerator by it. Okay. So this will give me 4 times 7, which is 28, over 35. Okay. Now I want to do the same thing with the 6 over 7. So I already know I have like 6 over 7, so I got to multiply the top and the bottom by the same thing, by something. The way I figure out what that is I say, well, what do I need to multiply 7 by to get 35? Well, it's 5, so I also need to multiply the top by that, so I get 30. Okay, so the denominator, now that they both have the same denominator, I know that the answer is going to have a denominator of 35. And the numerator is just going to be 28 plus 30. And I've kind of run out of room here. I left too much space, and then I got all squishy. Let's just scooch that over a little bit. Didn't lose anything today. Nope. Okay. So 28 plus 30 is 58. And 58, is that divisible by either 5 or 7? It's not divisible by 5, and it's not divisible by 7, so it won't simplify any further. Okay, let's try it again. So it may seem like these are a bunch of work, and they are at first when you start doing them. But once you get used to it, it cools down a little bit for you. So let's start with finding the least common multiple of 8 and 2. Here's another one that had a special trick to it. Remember, if one is a multiple of the other, then that is the least common multiple. Well, 8 is a multiple of 2, so the least common multiple is 8. Therefore, the least common denominator is 8. So I have 22/8 minus 1/2, and I need to rewrite these so that they both have a denominator of 8. Well, I messed that up. 22/8. 22/8 has already got the correct denominator. And you might already also notice that this first fraction is not simplified. We probably should have simplified that first. We could have, but we can leave it like this. This is fine. We'll simplify it in the end. 22/8, so we don't need to do anything to it. And we need to do 1/2. We need to multiply the top and the bottom by something so that I get a denominator of 8. Well, if I multiply the top and the bottom by 4, that'll work, because that'll give me 22/8 minus 4/8. So 22 minus 4 is 18/8. Okay, so 18/8 is the answer, but it's not the final answer because it's not simplified. So, and it's, the original wasn't simplified too, remember? So, let's see. 18 is 2 times 9, right? So 2 times 9. And 8 is 2 times 4. So let's cross those guys out. And we're going to get 9/4. Oops, ran out of room. You can't see what I wrote. So this is the final answer here. This was like the sub answer. Okay, let's try some more. We're just going to keep doing them. Going to do a whole bunch. So 1/3 and 1/4. First thing we need to do is find the least common denominator. So I've got a 3 and I've got a 4. So remember, we're just finding the least common multiple. Prime factorization of 3 is just 3. That one's not too bad. And the prime factorization of 4 is 2 times 2. So my least common denominator needs a 2 and a 3. Needs 2 2s and 1 3. So that's 4 times 3, which is 12. Remember, those were those two are relatively prime. So we ended up just multiplying the two together. Let me scooch this over here a little bit so I have a little more room. Okay. So I need to take 1/3 and 1/4, and I need to multiply the top and the bottom of them. I made that a little too big. Both by some stuff. So they both end up with a denominator of 12. Okay. So to multiply 1/3 by something, can't make this fraction bar the right size to my liking. I need to multiply the numerator by 4 to get 12, so that means I also need to multiply the denominator. I'm sorry, I multiplied the denominator by 4 to get 12, so I also need to multiply the numerator by it, so I get 4/12. And then 1/4 I need to multiply by 3 in the bottom, so I also need to multiply the top, so I get 3/12. So that gives me 4/12 minus 3/12, which is 4 minus 3 over 12, or 1/12. Okay. Now this one is the same thing as 1 over 1 minus 3 over 22. Whenever you have one where the denominator is just like a 1, or it's like a whole number, if you're doing a whole number, then just use the least common denominator as the denominator of the fraction. Okay? Because this is like asking for a least common multiple of 1 and 22, in which case the answer is just the number that's not 1. Okay? So I want to rewrite this as 22 over 22 minus 3 over 22. So that's 22 minus 3 over 22, or 19 over 22. Okay. Scroll down. All right, let's see. So let's try this one. Let's do my least common denominator work over here. Let's try to keep it kind of further away because before I kind of crowded my problem. So I got a 38 and a 17. 17 is already prime, but 38 is divisible by 2. Okay, so let's just do it up here. So 38 divided by 2. Oh, 2 times 19. Don't even need to do anything more. So my least common denominator needs a 2, a 17, and a 19. Actually, let me write it like this. LCM 2, 17, 19. So 2, 19 times 17 times 2 is 646. So my least common denominator is 646. Oh gosh, that's a big one. Okay, so let's just take it one step at a time. I need to do 5 over 38 and multiply the top and bottom by something, plus 12 over 17 and multiply the top and bottom by something so that they both have a 646 denominator. Okay. Oh, sorry, I didn't really do what I usually do where I do the boxes, but we needed one of each. Okay, well 38 just needs to be multiplied by 17. So I need to multiply the top and the bottom of this one by 17. And 17 needs to be multiplied by 38. So I need to multiply the top and the bottom by 38. So let's do 5 times 17 equals 85. And then 12 times 38. 456. Gosh, I do not want to have to simplify this one. Okay, but we'll do it. Plus 85. Okay, so to get the result, we now need to do 646, and then this is just 85 plus 456. Okay, so 541. 646. This one actually is not as hard to simplify as you might think. Okay, so we already know what the prime factorization of 646 is because we've got it written right here. It's 2, 17, and 19. So if 541 is going to, over 646 is going to simplify it all, 541 needs to be divisible by either 2, 17, or 19. So let's check. Is it divisible by 17? I know it's not divisible by 2. Nope. 541 divided by 19. Nope. So this is a completely simplified fraction. We don't even need to do anything. It's all good. Now, I'm going to show you a trick if you have a calculator like this to see if something is simplified. If you're not trusting yourself, I still recommend you learn how to do it by hand as I've been showing you because it's an important skill to have. And also you're probably taking a class where your teacher won't let you use a calculator. But if you are allowed to use a calculator, you can do this. And it's going to give you like a decimal, which isn't really helpful. But if you do math and then fraction, it'll convert it back to a fraction. But if that fraction could simplify, it would give you the simplified fraction. Okay. So if you don't have a TI-84 or TI-83, or you're not allowed to use a calculator, you can't do this, but you can still do it by hand as we just did. So let's try this now. Okay. So 6 is a multiple of 3. So remember, if you have one that's already a multiple of the other, the smaller one doesn't even contribute to the calculation. So we can just look at 6 and 10 here. And we know the least common multiple is going to need at least one 2, at least one 3, and at least one 5. And in fact, it's going to need one of each, right? So the least common denominator is just going to be 60. So I need to rewrite each of these fractions so that they have a denominator of 60. So I'm going to multiply 2 2/3 times something. And I'm going to multiply 5/6 times something. And I'm going to multiply 7/10 by something. So to get to 60, I need to multiply this one by 20 over 20. To get to a denominator of 60, I need to multiply this one by 10 over 10. And I need to multiply this one by 6 over 6. Okay. So that'll give me 2 times 20 is 40 over 60. 5 times 10 is 50 over 60. And 7 times 6 is 42 over 60. Okay, I'm kind of running out of room, so I'm going to come down here. I don't like doing it this way, but I got to do what I got to do. Okay, so now I know the denominator is 60, and I just need to add all of the numerators. Okay. So 40 plus 50 plus 42 is 82 plus 50, but I already started. 132. Okay. Now this one's definitely going to need to simplify, right? Because 132 is definitely divisible by 2. So is it divisible by... divisible by 3 as well. Yep, so there was only oh dang, I totally did not do the least common denominator. I did a common denominator. Anyways, it should have been 30. Let me restart. Now, I just noticed it here because I totally miscalculated when I did this. But I could have used 60, and I could have kept going, and it would have totally worked, and it's fine to use a number that's too big. It just would have made this a little, take it longer to simplify. But let's redo this. Let's do it right. I cannot multiply today. Sorry, y'all. Okay, so usually I have a student telling me, no, that's wrong. I need to multiply this by 10, and this by 10, and this by 5, and this by 5, and then by 3 and 3. So it actually leads to a good point that I wanted to tell you about later. So as soon as I finish this, I'll do it. So I've got 20 over 30 plus 25 over 30 plus 21 over 30. All right, so now we're going to get much smaller numbers. 25 plus 21 over 30, which is... Now I'm just like, don't believe any math that I do. 20 plus 25 plus 21 is 66 over 30. Okay. So 66 is 6 times 11. And 30 is 6 times 5. So those guys cross out, giving me 11 over 5. So I would have been able to get that even with the denominator of 60. So the point I was going to make that I kind of jumped the gun on by making a big mistake is technically you do not have to use the least common denominator. You just need to use a common denominator. So if you use a number that's too big, like 60, like I just did, You will still get the answer. It's just going to take you longer to simplify the fraction, okay? Which is maybe not that big a deal, okay? So if you're looking at something, like for example, let's look at, all of those already did it. If you're looking at something like this one, and you're like, you know what, I don't feel like trying to figure out what the least common denominator is. I'm just going to multiply all of them together, and that's the number I'm going to use. You could totally do that. If, like this one, I could have done 3 times 6 times 10 and just used that number as a common denominator and rewrote everything, and it would have worked, and I still would have gotten the correct answer. I just would have had to do a lot more simplification. So if all else fails and you cannot figure out what the least common denominator is, just multiply all the denominators and use that number, okay? Let's do the last one. So we have 10, 13, and 5, which I don't need to worry about because it's in the 10. So the least common denominator is 10 times 13, or 130. So I need to rewrite this as 9 over 10 times 13 over 13 plus 12 over 13 times 10 over 10 minus, so we got to make sure we don't lose that minus, 4 over 5 times 26 over 26. Okie doke. I'm going to go down this time because I'm running out of room. So let me just double check myself, because now I just do not, like I said, I don't trust myself anymore, because that was my third mistake or so today. So 9 times 13 is 117 over 130 plus 120 over 130 minus, what is that, 104 over 130. So this is equal to 117 plus 120 minus 104 over 130. So let's just do it here. 117 plus 120 minus 104 equals 133 over 130. So remember, you already have the prime factorization of this, of the denominator. So to figure out if it simplifies, you can just look over here and say, like, is this number divisible by a 2? Is it divisible by a 5? Is it divisible by a 13? Well, it's definitely not divisible by a 2 and a 5, and it's too close to 130 to be divisible by 13. But if you don't believe it, you can just, you know, stick it in here and see what happens. And you can see it's not. How much more do I have? Oh, there's a lot left on this. We'll finish this next time. Okay, so that's all I'm going to do today. I will finish up this packet next lesson. Hopefully I won't be so distracted, and I will not make mistakes that hopefully didn't confuse you too much. But yeah, I will put the video up on the Google Drive, and still won't have the answer key up because I'll wait until this whole thing is done before I put that up. Well, thank you very much.